So in 3.1, we are going to have a refresher about some basic trigonometric identities and then learn about even and odd functions. So remember that for any angle theta, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, which we can summarize by SOHCAHTOA. For any given angle, the side that is connected to it, so in this case, the connected side of an angle would be the adjacent side, and the side that is across from it would be the opposite side. The hypotenuse is going to be across from the right angle. Cosecant is a reciprocal of sine. Secant is a reciprocal of cosine. Cotangent is a reciprocal of tangent. So here's an example. If you have angle theta here, then sine is going to be opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, that's 8 over 17, 15 over 17, 8 over 15, and then we have the reciprocals. But what if we're given this? We're given that secant of theta is equal to 17 over 8, and theta is between 0 and pi over 2. So first off, let's determine where theta is. All right, theta is between 0 and pi over 2. So we know it's going to be in quadrant 1. Anytime you're given either a cosecant, secant, or cotangent, I recommend rewriting this as either sine, cosine, or tangent. So because secant is the reciprocal of cosine, we know that cosine of theta is going to be the reciprocal of 17 over 8, which will be 8 over 17. Okay, so we know that our angle is going to be in quadrant 1 because it's between 0 and pi over 2. We know that cosine is adjacent over hypotenuse, that's 8 over 17. Now you could do the Pythagorean theorem. You could say that a squared plus b squared is equal to c squared. But we know that from this problem that if one side is 8, the other side is 17, then the third side has to be 15. From here, sine of theta is going to be opposite over hypotenuse, that's going to be 15 over 17. Cosine is adjacent over hypotenuse, that's 8 over 17. And tangent is opposite over adjacent, which is 15 over 8. And again, feel free, I'm going through this, but feel free to pause the video at any time, note down any questions that you guys may have for me. Next one, we're given that sine of theta is negative 2/5. And this time they even tell us theta is in quadrant 3. So we are going to draw angle theta in quadrant 3. And we know that sine is negative 2/5. So SOHCAHTOA, sine is opposite over hypotenuse. So for angle theta, the opposite is negative 2, and the hypotenuse is positive 5, which means we're missing the adjacent side. So we can say a squared plus b squared equals to c squared. Now remember, it doesn't matter what a and b are because we're just adding them anyway, but c always has to be the hypotenuse, which is opposite the right angle. So we're going to have a squared, negative 2 squared is 4, 5 squared is 25. Subtract 4 from both sides, we get a squared equals to 21, which means a is going to be, we know we get a plus or minus anytime you square root a variable, but because distance can't be negative, a is going to be radical 21. But because we're going in the negative direction, it'll be a negative 21. Negative radical 21. So remember, if you go in the negative direction, so if you go to the left or if you go down, your values are going to be negative. So knowing this, cosine of theta is going to be adjacent over hypotenuse, that's negative radical 21 over 5. Tangent is opposite over adjacent. So for theta opposite, I'm going to label these. The opposite is going to be negative 2. The adjacent side is connected to theta, and the hypotenuse is across from the right angle. So opposite over adjacent is going to be negative 2 over negative radical 21. But remember, you have to rationalize this. So a quick refresher on rationalizing. If you have negative 2 over negative radical 21, negative over negative is positive. And then to rationalize this, you have to multiply both the denominator and numerator by radical 21. So we get 2 radical 21 over 21. Secant is going to be the reciprocal of cosine. So if cosine is negative radical 21 over 5, then secant is going to be negative 5 over radical 21. And again, using the same method, if you rationalize it, we get negative 5 radical 21 over 21. multiply both numerator and denominator by radical 21. Cosecant is a reciprocal of sine. So if sine is negative 2/5, then cosecant is going to be negative 5/2. And then cotangent will be the reciprocal of tangent, but take the unrationalized format. So take the negative 2 over radical 21, take the reciprocal of that, and that'll be radical 21 over 2. The negative over negative becomes a positive. Now, functions are even or odd depending on how their end behavior of the graphical representation looks. For example, y equals x squared is considered an even function because the ends of the parabola both point in the same direction and the parabola is symmetric about the y-axis. So we have to have two requirements for a function to be even. One is that both ends of the parabola point in the same direction over any graph, and the graph has to be symmetric about the y-axis. Remember, the y-axis is this vertical axis here. So this is symmetric about the y-axis, and both ends are pointing in the same direction, therefore it is even. Now, algebraically, to determine if a function is even, then if f of x equals to f of negative x, then the function is even. In other words, if you replace the x value with negative x, and it still equals to the f of x, then the function is even. Okay, for example, if we have f of x equals to x squared, and I want to determine what is f of negative x. So all I'm doing is I'm taking the x value and I'm replacing it with whatever's in the parentheses. The x is an input. So I replace the input with the parentheses. So in this case, it's negative x. Negative x to the second power is x squared. Therefore, f of x is equal to f of negative x. They both equal to x squared. And that makes this an even function by the algebraic definition. And I think there's a typo here. It should have been f of negative x. A function is odd if, for the opposite reason. The ends of a function, of an odd function, they have to go in opposite directions. So notice that one end goes to positive infinity, one end goes to negative infinity. So for an odd function, the ends have to go in opposite directions. And the parabola, it's symmetric about the origin, which means if you look at the origin, it's symmetric about it. It has the same shape on both sides. Algebraically, negative f of x equals to f of negative x for all x values. That makes the function an odd function. So for example, let's take f of x equals to x cubed, and we have to determine both negative f of x and f of negative x. So negative f of x is easy. Negative f of x, it means you take the x cubed and you simply add a negative in the front. That's your negative f of x. F of negative x means you take the input, which is the x, and replace it with a negative x. Now negative x cubed is going to be negative x times negative x times negative x, which is going to be negative x to the third power. So therefore, if you look at negative f of x and f of negative x, they both equal to negative x cubed. Therefore, by the algebraic definition, this is an odd function. Now in trigonometry, sine is an odd function, and cosine is an even function. Sine is symmetric with respect to the origin, and cosine is symmetric with respect to the y-axis. Notice that on both sides of the y-axis we have symmetry, and here for sine, both sides of the origin, we have symmetry. So by definition, sine of negative x will equal to negative sine of x, and cosine of negative x will just equal to cosine of positive x. And then since tangent is sine over cosine, tangent is going to be an odd function. So tangent of negative x equals to, and again, there's another typo, I apologize, equal to negative tangent of x. So please make sure you fix that in your notes. So odd functions are going to be sine and sine and tangent. So sine of negative x equals to negative sine of x. Tangent of negative x equals to negative tangent of x. Those are odd functions. And cosine is an even function, which means cos negative x equals to cosine of x. And then same thing with the reciprocals. So for example, if tangent of x is 3.5, find tangent of negative x. Well, we know that tangent is an odd function, so tangent of negative x equals to negative tan x. Now what is tan x equals to? Well, tan x is 3.5, so tangent of x will equal to negative tan x, which is negative 3.5. Sine of x equals to 0.9. Find sine of negative x. So sine of negative x, by definition, will be negative sine of x. Okay, so what's sine of x? That's equal to 0.9, so this will be negative 0.9. And then lastly, if cos x equals to 0.1, find cos negative x. So cos negative x is going to equal to cos x because cos is an even function. And cos x is 0.1, so that'll be 0.1. So as you can see, for tangent and sine, we take the negative value of sine and tangent for negative tan x, or tan negative x and sine negative x. For cos negative x, same value as cosine of x. Think of questions you guys have, and we will go over these in class.